Hey guys, welcome. This is our 10-1 video. We are jumping into finding area. So you probably actually know how to find an area of a lot of these items already from middle school math. And we're going to kind of build it up a little bit more. We're going to see some of our old friends like Pythagorean theorem pop up. We're going to see special right triangles pop up, and we're also going to see some trig pop up. So let's go ahead and jump right in. And first thing, let's get our vocab down. It's always our first step, if you will. And here we go. Area of a rectangle. This one's pretty easy. Base times height will help us find the area. Area of a parallelogram. Now, since parallelogram sides are slanted, we can't use the slant piece. We have to use the actual true height. So the height right here is h. And b, so we still do b times h, but the way we set it up is slightly different. And let's move to the next one here. Let's see. And the last one is a triangle. So the area of a triangle, if you kind of think of a triangle, it looks like half of a rectangle. And so it's 1/2 base times height, and we have a height and a base. So let's go ahead and jump into our first problem. And that is right here, finding the area of a parallelogram. So when we find the area of a parallelogram, we just are going to go ahead and do area equals base times height. Make sure you draw the picture here. Now, where the 90 is created, that's where you want to go ahead and pick the 2 points where they create the 90. So there's where the base and the height are. And so we're going to get 5 times 4. And we just do 5 times 4, and that's 20. And one of the most important things for us in this lesson is going to be units. So it's inches, and we have a square unit on it. So a lot of kids like to read this as 20 inches squared. That is not how we talk. It is 20 square inches, because it would be the equivalent of having 20 little 1x1 square inches would be representing this area. So it's 20 square inches, not 20 inches squared. Okay? All right, let's move on. This one's a pretty quick lesson here. Okay, so this next one's about trying to find a segment. So it's kind of an interesting looking picture here. And I don't know the height. So DE is the piece in question where I'm just like, what is this guy? I don't know what it is. Well, we can actually work this in a different way. So this is a great problem-solving skill where we got a tool and we got to think in a different fashion. How am I going to find this? Some students might say, let's try and use Pythagorean theorem. I see a right triangle here. I would say that's really smart. However, I don't know AE either. So since I don't know what that is, I can't use Pythagorean theorem. You might think, oh, let's try and do like SOHCAHTOA or something like that, but I don't have angle measures. I just don't have enough information. What I can do instead is I can use area. And I can actually find the area of this parallelogram, and I'll show you how. Okay, so you're like, but Mr. Smith, we don't have DE. Well, if you think about it, do you see how this piece and this piece form a 90? So there's my base and my height. So I can actually use 13 times 9 as the area of this figure. And I believe, what are we going to get? I think it's 117, but I'm not 100% sure. Let's see, 117. I was right. Okay, cool. So we get the area. So the area of this whole thing is 117 square inches. Okay? You're like, well, Mr. Smith, why is that useful? Well, I can now go ahead and say, look at the area is base times height. Now, if I look at it on the side, we had 13 and 9 as a base and a height, but we should be able to actually do the exact same equation using AB and AE. This time we don't know what the height is of DE, so we can go ahead and leave H as an unknown, or we could even put H in as segment DE. We don't know what it is, and we will find it. And our base is 9.4, and that's multiplication, by the way, equals, and we're going to get the area, which we already know the area of the parallelogram is 117. So I just really got to divide by 9.4 and do that to both sides. Now this one I don't know off the top of my head, so we're going to go ahead and use the calculator. And we're going to get about 12.4 because we're rounding to the nearest tenth, and we're going to call that inches equals DE. So this is using area to help us find a missing segment. So now all these problems are going to look different, so it's hard to really judge, but you got to use your problem solving skills to think about ways where you could rework the picture and the problem. So interesting problem. Alright, let's go on to our last one. Our last question is finding the area of an irregular figure, and the goal is basically to go ahead and break it down into 2 or 3 or 4 different types of shapes that we can find the area of. So if you can see, we got a square that we can find the area of. It is all congruent sides, so that's 6. So we can find the area of the square, which is going to be base times height, which will equal 6 multiplied by 6. So we get the area to equal 36. So that's one piece. And then we take the triangle. It has a height of 8, and this base piece right here is 6. So we have the area equal to 1/2, and that's going to be base times height. So 6 times 8. Half of 6 is 3. 3 times 8 is 24. Equals the area of that piece. Then we just have to go ahead and add them together. And so we add the two areas together, the area of the triangle and the area of the square. So we get 24 plus, that was a 4, it's a horrible looking 4, plus 36, and I believe we get 60 inches, sorry, 60 square inches to be the total area of this irregular figure. So a lot of times it's us using what we call composite figures to break it down and solve it. Alright? Okay, until then, I bid you farewell. This is an what did I call this? This is an opportunity for some extra credit. So here is your opportunity. Read this question and answer it correctly in your notes, and I will give you extra credit. So suppose the base heights of the squares in the triangle and the figure at the right are doubled to 12 inches, but the height of the polygon remains the same, which is this right here, 8. How is the area of the figure affected? So what's the new area? Alright, so anyways, we'll see later.